Hey, good afternoon, everyone. Welcome. Again, like Prem said, thank you so much for taking your time out on a Saturday afternoon. And hopefully, we've got some plans in the evening as well. You're in the right area for that as well. Yeah. So, my name is Bharath. I'm a senior software engineer at Mirantis. I work for the open source program office team. So, just a little bit about the team. What we do is we empower open source softwares. We use them internally, and then we also try to expose them and illuminate them to the world as well. um, as you all know, more lately than before, the adoption of open source, either in individual projects, development projects, or even enterprise, has become really good, right? So one of the latest shocking news from Microsoft is that they have literally open sourced Copilot, which is one of their really, really powerful tools, right? Might be wondering why open source, things like that, right? So there's obviously community, advantages and benefits, but apart from that, there's also benefits for the company. So the companies, although they open source, in fact, like GeekyAnts React framework, which Prem showed earlier, is one of the better examples of that. They're building such a powerful company and a team and a product around it, even though most of it is open source. One of the more powerful examples of companies that does this is Red Hat, right? So every product that is developed in Red Hat has an upstream and a downstream component. Upstream is the open source upstream version, and then the downstream is the company version. So almost like 95 plus percentage of the code will be same, contributed back to the community. About 5% or so will be certain enterprise features and security features, which is the value add that companies do, right? So that's what Mirantis is doing as well in almost all the work that we do. I'll talk about the project and everything in a bit, which again, from the roots, it's open source, right? So diving into this, the evolution of DevOps, if you see, has really come far, especially in the Kubernetes world. If you talk about it, right, on cloud, it started really simple. It was this offering where they said, "Hey, this thing works on my machine, but it doesn't work on your machine." The classic developer line, right? They said, "I'm going to solve that problem." So Docker said they'll solve that problem, but they solved that problem only to some extent. Kubernetes took that to the next level. So Kubernetes gave an entire ecosystem around that core idea where nobody can complain, "Hey, it works on my machine, not your machine, not my problem," right? So they said we'll standardize the way the tools are built, the tests are run, the package is, finally packaged and delivered to the customer. This whole process is standardized. And why Kubernetes became so popular is because the ecosystem that's built around it. So it's not just about one thing. You have an entire thing that is built around, for example, the security. There are so many products. Observability is so huge right now. Everybody wants to jump into observability, right? And then deployment is one segment as well, so on and so forth. So quickly, what it became is this maze of interconnected components across clouds, where you have to like sort of talk to hundreds of APIs and connect them in between. And this is the sort of the maze that it's become. And now, increasingly, and I know it says the future of intelligent operations, but I think it's no more the future; it's the present. Already, we are in a world where everything that we do is AI driven. If it's not, then it'll soon become AI driven. So AI has sort of become the centerpiece of everything that we develop, everything that we build, everything that we ship to customers, end users, enterprise users, whatever it is. It's gonna AI is gonna be there. So with that in mind, we need to build a really strong platform engineering, right? So how does platform engineering differ from typical DevOps? One of the core goals of platform engineering is to provide a self-service mechanism, a self-service portal where you don't have to depend on another team to take care of typical DevOps stuff. So for example, let's take an example, right? Let's say you want a Kubernetes cluster in AWS. How do we mostly do it today? You raise a ticket. What is life without tickets, right? So you raise a ticket, it goes to DevOps team, and then you wait. And then you follow up, and you follow up again. And if there's a delay, there's not much you can do. Escalate, go up the chain, and this is the whole cycle for every single time. But the promise of platform engineering is that you get a self, serviceable platform where the front end would look something like a basic form. You fill up the details like, hey, I want a 3 node cluster. It should run 16 gigs of RAM. It should also have a GPU. Let it run this particular image, Ubuntu base, or whatever specialized image that you want, or upload my own custom image. Click submit. That's it. It doesn't go to a team. Rather, it goes to a self-serving engine which takes in this request and then builds up a cluster in the backend, right? That's one of the promises. And if I just take a couple more from this list of what are the primary enterprise requirements, security and compliance becomes extremely important. So not just building a product, but keeping security in mind and then building security into the core of the product becomes extremely important. That's one of the main goals of platform engineering, right? Talking about the current situation in the market, right? So there was a survey done, last year in 2024, and 76% of the organizations said that we have multi clusters in our environment. And when I say multi clusters, it means two or more clusters, right? So we have AWS, we also have GCP, or we have AWS, and then we have Azure. So two or more, everybody has, because that's the kind of world we live in. Nobody wants to get locked in into one particular vendor, right? But the shocking thing is just 29% of them have actually a proper platform engineering basics laid into the foundations of their team. So this becomes really challenging to maintain, right? Now, when you think about a proper solution for this, of course, doing nothing is always an option, right? You can just say it's tomorrow's problem, see what happens, and then go with it. But eventually, the technical debt builds up and it will blow up in a way that 10 management folks will be on the line asking what happened, and then you do a RCA and blah, 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 right? So to avoid that, open source is an excellent option. Like I already mentioned, Kubernetes ecosystem is built around open source principles and technologies, and it's really good for the solutions that exist in the market. But the problem is there are so many solutions out there that what do you pick? What works best for you? So in any category, you see there are like 10, 15, 20 companies offering exactly the same thing, slightly different, right? So that becomes a complicated challenge for you to manage it. Then there's a proprietary solution. Yes, it's great. So if you just want one company doing everything for you for their particular cloud, it works well. But like I said, nobody wants to get vendor locked in, right? So we also what happened with the famous Broadcom VMware example, but there have been more examples. It's just that that's happened at such a large scale that everybody wants to get out of VMware now. That's where we have the enterprise grade open source solution, right? So what I'm going to talk about right now, hopefully you guys got the foundation of the problem we're trying to solve, and how we're going to solve the problem is what I want to talk about. So we take all the good parts of open source, we identify the projects that are doing well, both in terms of the core fundamental technological principles, as well as the community, the support, and the future growth, right? So we take them and then we create an entire solution out of it, giving an end-to-end experience for the user. And that's where Cordant comes into picture, right? So Cordant is developed by Mirantis folks. Um, and it primarily has like three main components, right? So this cluster management, state management, and observability. So starting with the last one's easy. No matter what platform you build, if you don't have a proper tracking mechanism, it's going to be useless. So day two, your engineers and your DevOps people will ask, how do I see the logs? How much am I consuming? What are the metrics? And the management people will ask, how much is costing me, right? So without a proper observability stack, the platform, however strong it might be, will not be a successful one. And that's why we built observability right into the stack. Then there's day zero cluster management, which talks about handling and managing and provisioning clusters, and state management, which talks about the same thing but for applications. So let's say you have like 10 Kubernetes clusters across AWS, Azure, and let's say on-prem OpenStack, right? But then one of the more common things that everybody does is install Cert Manager or Ingress. Now, typically, I would need to run a Python script or write an automation, pipeline, which goes and logs into all the 10 clusters, installs these scripts, and then manages it, right? But what we've done is by just configuring it at the top level, all these applications are installed across all the clusters, and it's easier to manage them on day two as well. That's state management. So this is the kind of stack that I want to help understand. The bottommost layer is the infrastructure stack. So that's your providers. So that's your VMware, the bare metal, OpenStack, AWS, Azure, and so on, right? And then there's the cluster management, state management, and observability. And on the right side, the observability stack is expanded. Okay. So we have something called as catalog. What this is basically an collection of services. So the same thing, the analogy for this is your Play Store, right? So Google built Android, and Android runs on every device. But what makes it awesome is not just the native apps that we get, but it's also the apps that people have built in the community, and then they're uploading it to the Play Store. And you, as a user, get to download it from the Play Store. That's what the catalog is. So as you can see, I don't know if you can actually see the examples out here, like Argo CD, right? Cert Manager, Dagger, External Secrets, and so on. We're continuously developing this. It started out with like 15, 20 apps, and already I think it's reached 40 or 60 services. Any application that has a Helm chart, it goes here and you can install it. And installing is very simple. You can just do Helm install and then the name of the service, and that gets installed on your cluster. So I mentioned we use open source components, right? So these are the open source, some of the open source projects that's used. For the cluster management, K0s and Cosmotron form the base, the core technologies. So as you can see, we've gone with a K0 trademark. So K0S is the Kubernetes distro. You guys have heard about Kind, right? That's one of the most common things or famous Kubernetes distros out there that everybody uses. K0s is a Kubernetes distro that's primarily supported by Mirantis, but it has also community engagement as well. Recently, we got accepted into the CNCF, so that was a big deal. And this is the most lightweight Kubernetes distro out there. It doesn't need a comparable compared to other distros out there. This runs as a single Linux process, as a system D process on your laptop, and that becomes your controller. So it's so lightweight that I can have my laptop as the control plane, and then I can add a Raspberry Pi as the worker nodes remotely and then support them, right? And a Cosmotron is the control plane manager for the same thing. And just mention about CAPI. CAPI is cluster API. This is directly under the Kubernetes SIGs, and this is the standardized way to provision clusters across clouds. And that's what we're using. So Kubernetes said, hey, it doesn't matter whether you're provisioning, Kubernetes on AWS or Azure or OpenStack. Follow these standard set of instructions. Follow the same guidelines so that we have a standardization, and that's the same thing that Mirantis is using too, right? And in state management, we're using something called Peltos. This is the core project, and then observability, Prometheus, Grafana, Victoria Metrics, OpenTelemetry, and so on, right? So before this, I want to mention one more thing. Just in this open source components, right? In the observability, we also have OpenCost and OpenTelemetry baked in. So what this gives is a powerful way to track all your costs across the clusters. Okay. So right now, OpenCost does support very good tracking in a single cluster. But what we've done is we've taken this OpenCost and then put our own logic onto it, which is again an open source project, KOF, right? Wherein you can track costs across clusters, which are across clouds. This is a very powerful feature. So if you're a manager, if you're the lead of a DevOps team and you want to understand how much money you're spending every month or every quarter, then this would be a single dashboard for you to manage them across. And just a note on Victoria Metrics, this is a extremely powerful time series database. So unlike your traditional databases for Kubernetes, where the metrics are huge in terms of volumes, the time series database is identified as one of the best ways to store data, right? So this is in the category of this is yet another category like SQL and non-SQL databases, right? No SQL databases. So this is another one called time series databases, where it's extremely efficient to store tons and tons and tons of data, and that's what we use. And to query that, we use OpenTelemetry, right? So all these again are available upstream, but they're packaged and configured in such a way that it's easy to use out of the box. So yeah, you as an individual developer, what I'd implore is to go ahead and try K0s. It's a very lightweight distro, like I said. You can run it on your machine and see how the control plane is coming up, and then you can add worker nodes also in your own machine, right? Or you can use another device and then add worker nodes there as well. So go ahead and explore Cordant, github.com/Cordant. We even do the project development over there as well, right? So thank you so much.